So what is that formula? You won't have to remember it. If we do number 3 in that, that is the height. Does anybody recall from memory the formula for the area of the kite?
Diagonals.
So Frank, I should say just this spot. Oh, you're
No, like you're good. Just in between. I don't know. Your camera's not showing a time limit, but it still says recording. Stay in between. I'm not past here.
What is that formula for a kite?
Diagonal 1, diagonal 2, divided by 2.
Ladies on YouTube, please. Thank you. Come in the room. Monica and Nicole are going to do better than not compete with us. The kite formula for the area of that kite, of that shape, is 1/2. It's sort of like the formula for triangles. Half base times height. You have half in the formula, but then you don't use base and height for a kite. You use what?
Diagonal 1.
The diagonals. You have diagonals across that kite. So you multiply the diagonals together, whatever those lengths are, and then multiply times 1/2 or divide by 2. So do they give you the lengths of the D1, D2 in that shape, Brandon? Yeah? Do they give you D1 and D2?
Yes.
Okay, so they actually give you that information. So it's really not that hard. It's just using the formula and knowing how to use it. That area then would be 1/2. And those two diagonals are, what? You have to know some properties of the kite. Let's look at this diagonal. Did they give you the entire length across? No, they didn't actually. They only gave you half. They said it's 5, right? But the property you know is what happens to this diagonal in the picture. What does that other diagonal do to it?
It bisects
It, right? So if you know that 1/2, then you know the other half. So the entire distance across. And then again, they didn't give you, oh yeah, but they did. The long one, the other diagonal, they did give you, just have to add those two pieces together, getting what? 15. So again, you just multiply the numbers, 5 times 75. If you can do the arithmetic there, half of 10 is 5. 5 times 15 is?
75.
Right? Again, we're doing area. So I would prefer that you communicate the units. This problem has units of millimeters. But because it's area, it's what kind of millimeters? Square. Right? So that's how you show your work. What are you going to do with this answer? What are you going to do with this answer? You're going to put it on the right hand side. And that's the spot provided for you. Okay, the next section, 4, 5, and 6 on this front one.
Wait, how do you do only 2?
Well, I'm not doing them all. Different formula. Look at the numbers they give you. Calculate the area. 4, 5, and 6 in that next section. They're asking again, finding the value of x. So here they're doing it a little bit differently. Like number 4, they do give you a shape, but they don't ask you to find the area. They ask you, they give you the area. And they ask you to find one of the sides. So it's 108 square feet. They want you to find that x side, which I can believe is this, and tell you this one is 12. So again, you're going to use the formula. This happens to be what kind of shape?
Rectangle.
It's a rectangle of some kind. It's parallelogram where the angles are right, 90 degrees. We don't know it's square. We know it's rectangle. But to find the area, it's base times height, right? So again, you won't have to memorize that formula for the test, but you must use it and find it for this quiz review. So the area is going to be the base 12, but times the, I don't know. But did they give you the area? Yeah. They gave you a value for that, so you just plug it in. And now you have to use your little bit of pre-algebra to be able to solve for x, Felicia. You've got 108 equal to 12 times x. To isolate x, you divide by 12. Again, I'm not going to teach the algebra lesson here in geometry. Those are things you should have gotten back in 6th and 7th grade. We're just using them now. So this tells you that x is 9 feet. Again, provide that unit for me. That's showing your work on the next page. Or in the blanks where you put your answer. I do want to give you some hint on 6. I'm not going to do it for you. Here's what you should be writing down as a sensor review. It's asking you to, what we're trying to teach you here, again, is how are the areas and perimeters related in proportion. And as my daughter and I were preparing for her final today in this course, the last thing I asked her was this. If you double the sizes of a shape, how does that change the area? This is just an example. If size is double, if all the dimensions of a shape is twice bigger now, if you do that, how does that change the area?
Doesn't the double?
No, it doesn't. It doesn't double. That's what we wanted you to learn back in the section, so get it now. There's a relationship with that though. If the lengths of the dimensions of this shape is 2 times bigger, it's double. Okay. And Nicole just said quadruple. How does that change the area? It quadruples. It squares the change of the length. It's 2 to the second power. So she's right. It's 4 times greater. You're writing this down, I hope.
What?
You're writing this down, I hope.
Oh, of course.
Right? If we change the length by 3, a shape is 3 times larger than it was originally. How are you changing its area? 3 to the second power. Again, you're squaring it. You're squaring that change to the perimeter. So that its area now is, if you triple the size of a shape, then you are 9 times increasing its area. 3 to the second power. One more time with feeling. If I increase the shape 4 times bigger, how much bigger is its area? 4 to the second power, which is 16 times bigger. Now that may seem that's kind of one of those things we share with you in this class that you're like, what? You mean if I make a milk carton 4 times bigger, it'll hold 16 times the amount of milk?
Really?
Inside? Absolutely. Well, actually it's 4 to the third power times milk. But it takes 16 times more material to make that carton of milk.
And it was powdered milk. It was 16.
If I make the size of the carton 4 times bigger. Okay? So that's the relationship. If they tell you the area, if they say the area has increased 25 times in a shape, and ask you to find this, the perimeter change, what would you do? They tell you this, how do you get back here?
Divide by the
Square root.
Square root it, right? Go the opposite way. Squaring, opposite, square rooting. So if you have the area, then square root that, you know that it's 5 times. You just change the shape 5 times bigger. Get it? Okay. So those are things that you were taught, and that will help you with problem number 6. So let's turn the page. In this section we talked about circles a lot. So we're going to look at the various aspects in chapter 11 that we talked about with circles. And we talked about circumference. That's pretty middle schoolish. I won't do that as an example. We talked of length of arcs. You didn't see that in middle school, so let's talk about that. Number 2. We're in the next section now, number 2. What? I'm trying to get the picture up here so we can point at it. We want to know what the length of a JK is with this little symbol over the top, so you need to be able to read that as an arc, right? But by the way, again, I want to mention, are they talking about this length of arc? They're talking about the long trip or the short trip?
The long trip.
It's the short trip. How do you know the difference? How do you know if they want to talk about the long? Because they could.
Oh no.
To talk, if they were asking for the long one, they need 3 letters. 3 points. If they want you to find the length of this arc, they need to go J, M, K to communicate that. That's the language that you need to be familiar with. Since there's only 2 letters, which kind of arc is it? We call it a minor arc. It's the short trip. It's the short trip between J and K, not the long one if they use 2 letters. Are you with me with that? Okay, so how do we find this JK with this information that they gave you? Remembering, again, we're just looking for how far would you walk if you walked that distance. Well, this is how much you walk, since they told you this was 79 degrees, of the entire length around the track, right?
Yes.
All we're doing is 75 degrees of the entire 360-degree trip. That's how much of the entire trip around it in degrees we're doing. Well, if we multiply that by the circumference of the whole thing, it'll tell us how far we walked before our dog went to the rescue. Whatever that analogy is. So, to find the circumference, that's this formula, 2 pi r, right? From elementary school. Formula for the circumference. So all we need to do is have the radius. Do we have the radius?
Yes.
Yeah, I said it was 7. 7 what? 7 inches. So all I have to do is find the circumference and then multiply it by the part of that circumference we walked. It's the part times the circumference. The entire circumference. So, and then we multiply those 2 together and we get the answer. Okay. With your handy dandy Blue's Clues calculator, all you have to do is multiply those things out and you get approximately 9.2 inches. That's how far you walk. So that's number 2 as an example. In that next section, they're not talking about trips around walking or parts of circumference. They're talking about parts of areas, and we call these sectors. Remember the coffee filter thing activity that I had you do? Okay, these are sectors. So if we find this area, problem number 4 is as good as any. And problem number 4 is asking us to find how much of that area of the shaded region. That's called the sector. And we have an incredibly accurate circle drawn on the board. And that center point is T, and we've got something like this that's UV.